In this problem, we will show that the two functions, given functions e to the power ax sin bx and e to the power ax cos bx, they are linearly independent by the help of or with the help of Wronskian. We know Wronskian is defined as the determinant of y1, y2, where y1 and y2 are two functions or solutions of the differential equation, and y1 dash is the derivative of first derivative of the solution y1, and y2 dash is the first derivative of the solution y2. And if you find out the determinant, then that will give you the Wronskian, and if Wronskian is not equal to 0, then the solutions or functions are linearly independent, and if Wronskian is equal to 0, then they are linearly dependent. And here it is given to show that the two functions or two solutions of any differential equation are linearly independent. So we will show that the Wronskian is not equal to 0. The given function or solution is y1 is equal to e to the power ax sin bx. So if you find out the first derivative, then y1 dash or derivative of e to the power ax sin bx with respect to x, that will be equal to this is a product function. Your first function derivative of the second plus second function derivative of the first. So first function is e to the power ax, derivative of sin bx is b cos bx, plus the derivative of e to the power ax is a e to the power ax into sin bx. Similarly, the second function is given y2 is equal to e to the power ax cos bx. So derivative of the second function, that is y2 dash or derivative of e to the power ax cos bx with respect to x, and this is also a product function. So first function derivative of the second plus second function derivative of the first. So first function is e to the power ax, derivative of cos bx is minus b sin bx, plus the derivative of first function, that is e to the power ax, is a into e to the power ax into cos bx, then e to the power ax, that is the first function, and derivative of second is b into derivative of the first function, that is e to the power ax, is a e to the power ax into the second function, that is cos bx. So you have four values y1, y2 and y1 dash and y2 dash. Now we'll find out the Wronskian. To find out the Wronskian, we have to find out the determinant. So determinant of this is y1, this is y2, and this is derivative of y1 or y1 dash from this to this, these two terms, and these two terms are the derivative of y2 dash. We have found out here that this is the derivative of y2 dash, this term. So this is derivative of y2 dash. Then we will find out the determinant. To find out the determinant, you first multiply e into a to the power x multiplied by e into a to the power x, that is e into 2a to the power x, then sin bx multiplied by minus b sin bx, so minus b sin square bx, then multiply e to the power x with this term, that is e to the power a e to the power ax into cos bx. This will be equal to a e to the power 2ax into sin bx into cos bx. Then we multiply these two terms with this term, then e to the power ax cos bx multiplied by e to the power ax b cos bx, that will be equal to, and you have minus, so minus e to the power 2ax b cos bx that will be equal to b cos square bx, then multiply this with this, so minus e to the power 2ax a sin bx multiplied by cos bx. Here you have sin bx, here you have cos bx, and these two terms, they are similar, they are same. This is plus and this is minus, so they will cancel, and from these two terms you take common e to the power 2ax, and if you take e to the power 2ax common, then in the bracket you have sin square bx plus cos square bx, and sin square bx plus cos square bx is equal to 1. So Wronskian will be equal to minus b e to the power 2ax. So Wronskian is not equal to 0. Hence the functions are linearly independent, or the solutions of the any differential equation, they are linearly independent. So it is very easy to find out whether the solution of a differential equation, they are dependent or independent by using Wronskian. If Wronskian will be equal to 0, then they are linearly dependent. The two solutions of the differential equation, they are linearly dependent, and if Wronskian is not equal to 0, then the solutions, two or more solutions of the differential equation, they are linearly independent. Thank you.